Let's take a look at solving linear inequalities in one variable. And first off, we're going to have initially, then it becomes more complex in intermediate and college algebra, but initially we're going to have four different forms. We'll have where x is less than a number, like x is less than 1, where x is less than or equal to a number, like x is less than or equal to -3, x is greater than a number, like x is greater than 5, and x is greater than or equal to a number, like that. Now you can have any number in there. I just put numbers there so we can see something. We have something called set builder notation. Now I'm going to go ahead and give you all the different forms here. Not all of them are used in each particular problem set. Set builder is easy. We put we take our form and we put curly brackets around it and we put x with a vertical bar. Now that vertical bar reads such that. So this says a set of all x values such that x is less than 1. Again, put the curly brackets around it, x with a vertical bar, and x is less than or equal to -3. Same thing here. Set builder is simple. It's always curly brackets, x vertical bar. Now remember what the vertical bar means is sometimes kind of tricky. Again, the set of all x values such that vertical bar is such that x is greater than or equal to 7. Well, the next thing is interval notation. Now this is x is less than 1, and it looks like this. This is x is less than or equal to -3, and it looks like this. This is x is greater than 5. Looks like that. This is x is greater than or equal to 7. And it looks like this. Okay, now let's talk about what some of these different elements mean. This symbol you see, it's supposed to be an 8 written sideways, but I can't draw an 8 sideways very well, so I just do two O's next to each other. That indicates infinity. Now infinity is a large number you can never reach. Because if you think about it, what's the largest number you can think of? 1 trillion? No. 1 trillion plus 1 is larger. Well, 1 trillion plus 2 is larger. You can keep adding 1 onto it and get a larger number. So you can never find the largest number. Now negative infinity, that's a small number you can never reach. You know, what's the smallest number? -1 trillion? No, -1 trillion and 1 is smaller. -2 trillion. So you can keep finding smaller. Now the infinities always have parentheses on it. Parentheses means it doesn't include that number. You can't reach it. Now here we have x is less than 1, which means it's less than, so it doesn't include 1, so there's parentheses there. Now here we got x is less than or equal to -3. Equal to means it includes -3, so we'll put a bracket on it. X is greater than 5, so parentheses, greater than or equal to 7, so bracket here. Now if it's a less than, it's going to negative infinity always. If it's a greater than, it's going to positive infinity. And then you just need to remember what these lines, a line underneath here, the equal to part means bracket. Well, then we have our graph. And graph is very easy if you got interval notation. Now here we got parentheses on 1, so parentheses on 1. And we're going to negative infinity, so we're shading to negative infinity. And that would be our graph. This one, bracket on -3, bracket on -3. And it says it's going to negative infinity, so we're shading to negative infinity. Now this one, parentheses on the 5, parentheses on the 5. We're going to positive infinity, so I'm shading to positive infinity. Bracket on the 7, bracket on the 7. Going to positive infinity, so I'm shading to positive infinity. So that would be our graphs. Now this is a table you should use until you start getting more comfortable with these different notations. Let's look at our first problem. Okay, so it says x is less than or equal to -8. It says graph each inequality on a number line and write each inequality in interval notation. Well, this is x is less than or equal to a number. So if I come up here, I'm looking for a form where we have x is less than or equal to a number. Well, that's our second one here. If I come over here, this is what our graph's going to look like. So this is exactly what it's going to look like, except for the negative 3 will be negative 8. Like that. And that's our graph. Now it says write down your interval notation. Again, I said it matched this form, so I come over here. This is exactly what our interval notation is going to look like, but instead of a negative 3, we'll put a negative 8 there. Whatever number we have here. And those will be our answers. Now let's take a look at this second one. Give us a graph. Looks like it goes from 2 and then shaded to the right. It says use interval notation to express the inequality shown in each graph. Again, until you get comfortable with it, go up to your graph here. I'm looking, or to our table. I'm looking for a graph that's shaded to the right that has a bracket on it. Well, a fourth one. Bracket shaded to the right. So it matches this. And it says it wants interval notation, so I come over to the column for interval notation. And this is exactly what it's going to look like, but instead of a 7, we'll put the number we have down here, which is a 2. And that'll be our answer. Now that's just getting you used to working with interval notation, well, not set builder. There's no set builder on this one, but later on we'll see set builder. Let's talk about how to solve a linear inequality. Solving a linear inequality. We have a note up at top. It says at any step, combine like terms and combine numbers. Then our first step is get rid of parentheses. And we do this via the distributive property. Our second step is to get rid of fractions. And you multiply everything by the LCM of all the denominators. Step 3, get everything with an X on the left side, numbers on the right. Technically, it doesn't matter which side you get it to, but if you go ahead and put them on X's on the left side, it'll match our table up above perfectly. You don't have to worry about flipping things around. Step 4, divide both sides by the number in front of the X. So divide both sides by the number in front of the X. And we have a note at the bottom. It says if you multiply or divide both sides by a negative number, flip the inequality symbol. Okay, let's take a look at some problems dealing with this. That x plus 7 is less than or equal to 2. And it says solve the inequality, express the solution set in set builder and interval and graph it. So I want you to do all three here. Okay, we're going to go through our steps here. First step is get rid of parentheses. Don't have any. Second step is get rid of fractions. Don't have any. Third step, get everything with an x on the left side. We're talking about terms. Get everything with an x on the left side, numbers on the right. So I'm going to take the 7 and move it to the right side. Now, just like when we're working with equations, when you take anything across your inequality symbol, the sign changes. So positive 7 becomes a negative 7. Now, our note up at top says in any step combine together numbers. 2 minus 7 gives us negative 5. Now, this is already solved for x, so x is by itself. And that's our goal, so we don't have to do step 4 now. Well, we want to put it in set builder. Set builder is easy. I don't even need to look at the table up above. Set builder, you just put curly brackets around it, and then x with a vertical bar, x such that. Now, interval notation. Now, without looking at the table, I mean, you can if you need to, but less than means it goes to negative infinity. Less thans are always going to negative infinity. Now, infinities always have parentheses on them, so I'll put that there. Now, this is less than or equal to. So the equal to part on there means this has to be a bracket. If it was just less than, then it'd be parentheses. Now, if you have your interval notation, the graph is very easy. Bracket on negative 5, bracket on negative 5. And it's going to negative infinity, so I shade the negative infinity. And those would be our answers. So let's take a look at another problem. We've got negative 8x is greater than or equal to negative 24. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on one side, numbers on the other side. That's done. Everything with an x is over here, numbers over here. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by negative 8. Now remember our note up at top. If you multiply or divide both sides by a negative number, when we're dividing both sides by a negative 8, then you flip your inequality symbol. So the greater than or equal to becomes a less than or equal to. These negative 8s cancel. And then we got x is less than or equal to negative 24 negative divided by negative is positive, and 24 divided by 8 is 3. Set builder, well, curly brackets, x with a vertical bar. So it looks like that. Interval notation. Well, it's less than, so it's going to negative infinity. Less thans are always going to negative infinity. Now, infinities always have parentheses. Less than or equal to, that means that's a bracket there. Graph is very easy. If you got the interval, bracket on the 3, bracket on the 3. It's going to negative infinity, so shade to negative infinity. And those will be our answers. Let's look at this one. 3x minus 5 is greater than 7. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take negative 5, move it over to the right side. Again, when you take anything across your equals, the sign changes, so negative 5 becomes a positive 5. Now our note at the top says in any step combine together like terms, combine together numbers. 7 plus 5 gives us 12. Last step, divide both sides by a number in front of your x. Well, number in front of x is a 3, so we'll divide both sides by 3. And those 3 is going to cancel. And 12 divided by 3 is 4. Okay, set builder. Put curly brackets around the x with a vertical bar. X is greater than 4. Now interval notation. It's greater than, so it's going to positive infinity. So this will be 4 to positive infinity. Infinities we can never reach, so that's parentheses. Now its x is greater than 4, which means it doesn't include 4. So this would be a parentheses. If it's greater than or equal to, that's where you put the bracket. Again, the graph is very easy. Parentheses on a 4, parentheses on a 4, and it's opening in the same manner as this is, to the right. And we're going to positive infinity, so we're shading to positive infinity. And that would be our answers. Well, let me start a new page here, and then we'll take a look at the next problem. 6. So we got negative 5 times 2 minus 3x is greater than x plus 4. First step, get rid of parentheses. Well, here we got a negative 5 in front of parentheses. That means multiplication. So we're going to take negative 5 times 2 and negative 5 times negative 3x. Now negative 5 times 2 is negative 10, and negative 5 times negative 3x gives us a positive 15x. Now our note actually said to if you multiply or divide both sides by a negative number, flip your inequality symbol. Now here we're not multiplying both sides by a negative number. That's specifically if you go ahead and you put that in yourself, where you multiply both sides by negative 3, for example. This is actually just part of the problem. So don't confuse this and think you need to flip the inequality at this point. Okay, second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side. So I'll take this x over the left side and get numbers on the right side. So I'll take negative 10 and move it over here. Take anything across your inequality symbol, the sign changes. So the positive x becomes a negative x. And negative 10 becomes a positive 10. Now our note up at top says any step combined together like terms. 15x minus 1x gives us 14x. And 4 plus 10 gives us 14. Well, last step. Divide both sides by a number in front of your x. So we're going to divide both sides by 14. And those 14s cancel. And we get x is greater than 1. 14 divided by 14 is 1. Set builder. Put curly brackets around it. X is the vertical bar. I read such that. Now x is greater than. Greater than is going to positive infinity. So we got 1 to positive infinity. Now infinities always have parentheses on them. Since this is a greater than, means it doesn't include 1. So that we put a parentheses on that. For the graph, parentheses on 1, parentheses on 1. It's going to positive infinity, so I shade to positive infinity. And those would be our answers. Let's look at our next one. 7x minus 2 is greater than 1/4 times x minus 3. Okay, first step, get rid of parentheses. We got a 1/4 in front of this parentheses, so we're going to take that 1/4 and multiply it times the x and times the negative 3 using the distributive property. Well, 1/4 times x and 1/4 times negative 3. So we get 7x minus 2 is greater than 1/4 x minus 3/4. Now second step. There you go. Second step is we want to get rid of fractions. So multiply everything by the LCM of all our denominators. Now we got two denominators, but they're the same. They're both 4, so our LCM would be 4. So multiply it times the 7x times the negative 2 times the 1/4 x and times the negative 3/4. Now those 4's cancel and those 4's cancel. Excuse me. 4 times 7x is 28x. 4 times negative 2 is negative 8. Over here we got 1 times x, or just x, and then here we're left with negative 3. Okay, third step. Get everything with an x on one side, numbers on the other. So I'll take this x, move it to the left side, and take the negative 8 and move it to the right. Anytime you take anything to the other side, the sign changes. So the positive x becomes a negative x. The negative 8 becomes a positive 8. Well, we want to combine together like terms at any step. 28x minus x gives us 27x. Negative 3 plus 8 gives us 5. Well, our last step, divide both sides by the number in front of your x. We'll divide both sides by 27. Those 27s cancel. And we got x is greater than 5/27. And hopefully I haven't made a math error somewhere there. Kind of a little bit distracted. X minus 3, let me double check it. Yeah, it looks right. I got a spider in my room. I'm sitting there watching it. I hate to kill any living thing, but it kind of looks pregnant. So I don't know if I want little babies all over my room. I don't think it's a brown recluse or anything like that, just a nice spider. Anyway, yeah, I'm distracted. Okay, so a set builder. I'll put curly brackets, x vertical bar, x is greater than 5/27. Now our interval notation, it's greater than, so it's going to positive infinity. Infinities always have parentheses on them. X is greater than, it doesn't include that, so we put parentheses there. And graph-wise, parentheses on to 5/27, parentheses on to 5/27. We're going to positive infinity, so we shade to positive infinity. And that'd be our answer. Let's look at the last problem here. 7x minus 3 times x minus 2 is less than or equal to x plus 4. Okay, first step, get rid of parentheses. We're going to take this negative 3, multiply it times the x, and multiply it times the negative 2. Well, negative 3 times x is negative 3x. Negative 3 times negative 2 gives us a positive 6. Now at any step, combine together like terms. 7x minus 3x gives us 4x. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on one side, numbers on the other. So I take the x over the left side and take the 6 over to the right side. Anytime you take anything across your equals, the sign changes. The x becomes negative. The 6 becomes negative. Combine together like terms. 4x minus x is 3x. 4 minus 6 is negative 2. Let me just double check that. Okay, last step, divide both sides by the number in front of our x, which is 3. Threes would cancel there. And we got x is less than or equal to negative 2/3. Now it's less than, so it's going to negative infinity. Infinities always have parentheses. Now it's specifically a less than or equal to, which means this has to be a bracket. I didn't put set builder, did I? Okay, you may have to go, Mr. Spider, or Mrs. Spider. Okay, set builder, put curly brackets, x with a vertical bar. X is less than or equal to negative 2/3. Okay, the graph. Bracket on negative 2/3, bracket on negative 2/3. Shade, we're going to negative infinity, so we're shading negative infinity. And those would be our answers. And actually, that's the end of that section, too.